Alright, meteorology. Severe weather is a significant hazard to the safe operation of all aircraft. Severe weather, severe weather is a significant, okay. It is our duty as pilots to reduce this hazard risk with the understanding of basic principles of weather as well as employing all info available to avoid dangerous situations. Weather we will encounter in the Northeast: thunderstorms, turbulence, wind shear, icing, yes, icing even in the summer. This was a picture last summer outside of the hangar during the daytime coming over Oxford. I think that's Oxford. Yeah, that's Oxford. It's 121 right there. Not so nice. Alright. Thunderstorms, there's 3 stages of thunderstorms. You got the towering cumulus stage, the mature stage, and then the dissipating stage, and that's basically when you're going to start getting the rain. Isolated thunderstorms, the picture of isolated thunderstorms, you can see that they're just more scattered, or they're not scattered, because then you got scattered. Picture of scattered right here on a radar. Alright, and then you have frontal, which is basically always on the leading edge of a frontal there, which we never get these in the Northeast, as you guys know. That's a joke. They may contain strong wind, heavy rain, hail, turbulence, wind shear, and ice. Things to consider when departing in the vicinity of thunderstorms is cell location at the time of your departure, cell movement, which way it's going, if it's heading towards you or if it's heading in the direction that you're going, cell intensity, flight path intentions. Don't be a hero. If it looks bad, it probably is. Take a conservative philosophy regarding operations in the area. Regarding operations in areas of severe weather. Not sure why he put this up here, other than the fact that you can see that just going around a system, going around a storm, giving yourself a different flight plan to. As you see, this guy split between 2 sets of systems going into Denver. Versus this one, okay, I see where he's going at. So with this one, you want to put yourself around it, deviate around it, change the flight path, whatever you need to do. With this one, you can see that it looks like this guy just tried going right through it. Probably couldn't get through, put himself in a hold, decided he could get through it, then left, realized he couldn't get through it, turned around, and was like, probably at this point I'm committed, turned back around, and then basically went through some probably pretty good bumps there going into BWI. Be on the same page as your co-pilot. Voice any and all concerns to your PIC or SIC. Discuss techniques to be used in whatever circumstances you are facing. Have a way out. Discuss alternatives and other options when facing severe weather. Using onboard weather radar. Apparently Andy says to use it. When using the onboard weather radar, the following guidelines shall be used. If temperature at cruise is 0 degrees C or above, avoid all echoes indicating sharp and shear returns by at least 5 nautical miles. If the echo is irregular, indicating the presence of hail or tornadoes, avoid by at least 10 nautical miles. When operating above flight level 230, avoid all echoes by at least 20 nautical miles. Utilize the above distances when overflying a thunderstorm, unless the altitude difference is greater than 2,000 feet. The following radar returns indicate the presence of hail, tornadoes, or extreme turbulence and should be avoided in all instances. It's going to be hook-shaped echoes, U-shaped, scalloped, and narrow extension of the primary echoes. So you say here that we got a U-shaped echo, followed by a finger echo, the scalloped edge echoes, and then the hook. Usually the hook is what's going to be associated with tornadoes. All right. I know that he doesn't talk about it in here, but does anybody remember what the formula was? It's like your altitude. Come on, caravan school guys. I know they teach that there. You remember?
I wrote it down.
No.
I don't remember.
Yeah. So, alright. There is a formula. I really still don't think it works. A few more notes on radar. No flight may be initiated under IFR or night VFR if reports indicate thunderstorm or other potentially hazardous weather conditions that can be detected with airborne thunderstorm detection equipment unless the equipment is in satisfactory operating condition. Do not intentionally fly nor accept vectors from ATC to within 20 nautical miles of the edge of a moderate or greater thunderstorm cell. Determination of thunderstorm intensity should be made based on the onboard radar and ATC reports. If the weather radar is inoperative and thunderstorms are in the route of flight, the crew shall remain in VMC conditions and ask for assistance from ATC. Because ATC radar shall not be substituted for aircraft radar due to the uncertain positioning and blind spots of the ATC system, if unable to proceed under these conditions, the flight shall either divert around the weather, return to the departure airport, or land short of the troublesome weather. Wind shear. All right, just got the diagram here of basically wind shear. All right, what's proper recovery for wind shear? On a departure like this or something like that, what would you want to do in your aircraft?
Maximum power.
Max power and what else?
Pitch for the shaker.
What's that?
DX.
Yep. What did somebody else say?
Pitch for the shaker.
Pitch for the shaker. Max climb. Get on out of there.
Does a caravan have a shaker?
Pitch for the stall.
Doesn't have a stall.
It probably already is going off. The most prominent meteorological phenomenon that causes significant low-level wind shear problems are thunderstorms and certain frontal systems. Low-level wind shear is hazardous during takeoff and departure, or approach and landing. It can exist on all sides of a thunderstorm cell, but most significantly within 15 nautical miles in front of the actual storm. Alright, so kind of see what's going on here with the coming up to the storm. You got that downdraft hitting the ground, causing that gust front. Big airplane. The most prominent weather phenomenon that causes significant low-level wind shear problems are thunderstorms. Didn't we just talk about that? Temperature differences across the front and the speed the front is moving determine the strength of the shear. PIREPs are an important source of information on wind shear occurrence and strength. Alright. So if you were coming in and you're cranking along in your caravan going into White Plains and Global Express in front of you said they got plus or minus 10 on a low-level wind shear, you're probably going to have worse or less than the Global for low level. What?
Worse.
Could be. You know, if it was a 172 reporting that, the caravan's about the same. Remember to report it if you have it. Help each other out, make PIREPs when possible, and chat about conditions on 2277. Everybody knows that that's our company frequency. Turbulence may or may not be associated with wind shear depending on wind speed and gusts at the time. The best way to combat shear on departure is to delay the takeoff if possible, or plan the departure route to prevent encountering forecast or expected wind shear conditions. During approach and landing, brief for possible shear, monitor power, pitch, attitude, airspeed, and vertical velocity. Do not depart into or in flight. Proceed into an area of reported severe turbulence. Weather forecasts of severe turbulence should be carefully considered, and an election to not depart will always be supported. However, if you should always take it in, you should always take into consideration that the difference between forecast and reported conditions can vary greatly. Can we depart into forecast severe turbulence? Forecast?
I believe so.
It has to be known.
You can't depart into known severe. Factors to consider. Aircraft type, altitude of the report, location, and severity. So that's all for PIREPs when you're reading or getting PIREPs. Do not fly into known severe or extreme turbulence. If severe turbulence is encountered, immediately reduce to below maneuvering speed and fly the attitude of the aircraft. Alright. If you are coming up to an area that is known to have turbulence, don't wait to slow down till you get there. That's a big no-no. Alright. Do not try to turn back out of the area as you may have already gone through the worst of it. Make all efforts to avoid towering cumulus buildups and lenticular clouds. Be alert to descending down into a narrow valley when strong winds have created mountain wave effect over the valley edges. It is possible the entire valley may hold violent disturbed air, aka St. Bart's. Anticipate possible clear air turbulence at the tropopause boundary, especially during winter months and in the vicinity of the jet stream. You could tell he did this on a Mac.
Just heroes?
No, this is Andy's. Alright. So just basically diagrams going on here, the tropopause, the frontals, and near the equator. Check and make sure seatbelt sign is illuminated if you have it. If you don't have it in the commuters, turn around and tell your people to put their seatbelts on. Not that they're going to listen to you. Adjust airspeed and power setting as necessary for turbulent air penetration. Fly the attitude. Do not change airspeed once adjusted for maneuvering speed or attempt to change your altitude. Report the turbulence. If needed, request a block altitude if unable to maintain altitude. After the encounter, perform a careful post-flight inspection. Icing. Although it's summer, ice is something we should think about, especially on longer trips in PC-12s where you will be flying over a greater distance with a greater potential for changing weather and at higher altitudes with cooler temperatures. Just last week, this was now 2 weeks ago, there was 3 feet of snow, 3 feet of new snow in upstate New York. So this was around Memorial Day weekend. That's a picture of it. Happy Memorial Day. Just as with turbulence, never fly into areas of known severe icing. Forecasts of severe icing should be carefully considered, and an election of not to depart will always be supported. However, forecasts and reported conditions can all vary. Things to consider, once again, PIREPs, aircraft type, altitude, severity, and location. When more than light icing is encountered, attempt to change altitude in order to exit icing conditions. Normally a change of 2,000 to 3,000 feet will get you clear of the icing conditions. Monitor the ice buildup on protruding parts of the airframe, such as the temperature probe on the Caravan. Ice will build up on pointed surfaces faster than spread out surfaces like the wing leading edge. Have available anti-ice equipment on and operating as applicable per aircraft before entering icy conditions. If ice is built up on the inlets of a turbojet engine, the crew should use extreme care in selecting de-ice due to the possibility of ice ingestion causing an engine surge, compressor stall, or a total failure. Pre-flight weather planning. Consider all weather information pertinent to the route. Weather information should consist of at least the following when available: weather depiction charts, radar summary charts, prog charts, high-level significant weather progs, severe weather outlook, flight service briefings, PIREPs, and that's all we had at the end there. Ending with PIREPs. And then when adverse conditions are anticipated, flight crews should monitor in-flight weather developments through regular use of the following sources: flight service station, en route flight advisory service, transcribed weather, scheduled weather, in-flight weather advisories, SIGMETs and AirMets, PIREPs, and air route traffic control as well. Good thing that we do up here, especially if you guys are running shuttles all day long, is we have a lot of people in the office that know how to read weather, so you can always get on 2277 and ask them. Okay, not a lot, all right? Some. All right. The previously mentioned reports and forecasts should be obtained from the following sources: domestic, U.S. National Weather Service, including contract agencies, sources approved by the U.S. National Weather Service, source approved by the FAA, such as flight service stations, SAWRS, LAWRS, or AWOS, contracted sources such as Universal Weather Services. When in doubt, the validity of the report of forecast, ask the chief pilot. International sources. Any active weather office of a foreign state that subscribes to the standards and practices of ICAO conventions. These will be located in the ICAO Regional Air Navigation Plans, MET tablets, or the APIS of the individual states. I think that's supposed to be AIPs, not actual apostrophe S there. The equivalent National Weather Service of the country of operation that is used for commercial IFR operations. Then ask your chief pilot if you're unsure, or an experienced pilot. And apparently that was the end of his presentation.